Alright, we've come to the end of this unit on basic polynomials. It's really part one of a larger unit on polynomials. Obviously, we're dealing with basic polynomials this time. Next unit will be about more advanced polynomials. But this will be a review for the test that's coming tomorrow. So, domain. Now, as you look at this graph, you're supposed to imagine that it continues forever, like so. Okay, so even if those arrows aren't shown, you should assume when it runs to the edge of the graph that it keeps going. Now, the domain is the x values of the graph. Okay, so you're asking yourself how far to the left does it go and how far to the right does it go, and that will be the domain. Because this graph continues to drift left forever, the domain starts at negative infinity. But then it also goes right forever, so that's positive infinity. So the domain is negative infinity to positive infinity, left, right. The range is the y values included in a graph. And you want to put them in order from least to greatest. So the range will always be from bottom to top. Now the bottom of this graph, well, you can see the arrows. This goes down forever. So we're going to start off at negative infinity, because that's the bottom of this is negative infinity. Alright, there is no bottom. So we'll go negative infinity to the top. The top of the graph is right here. Alright, this is 4 point something. Alright, I'll call it 4.7. And we'll put a nice square bracket on it to show that we're including this value. It hits it, that 4.7 is one of the values on the graph. So it hits 4.7, 4.7 is included. So that's the range, bottom to top, negative infinity to 4.7. Okay, now intervals of increase. Yeah, maybe I should do this on all of these. So you have to be careful whether you're talking about x values or y values. So when we did the domain, we were talking about x values. When we did the range, we were talking about y values. Now, as we do the intervals of increase and decrease, these are all x values again. Okay, increase and decrease, we are talking about x values. Just like the domain. You have to look at the graph from left to right. So if I were to travel across this graph from left to right, part of the time I would be going uphill and part of the time I'd be going downhill. Everywhere I go uphill is going to be an increasing part of the graph, and downhill will be decreasing. So starting from here, okay, over at negative infinity, starting over here in negative infinity because I'm on the left, not because it's pointing down. So it's starting from the left, starting from negative infinity. Okay, I come in from negative infinity, and at first I'm going up. I'm increasing. This is an increasing part of the graph until it gets to here. Alright, then it changes, and then it's decreasing as I go from here to here. Okay, that's decreasing. And then it changes, and then it's increasing again as I go to here, increasing. And then it changes again, and I find myself once again going downhill. Okay, and as I continue on to positive infinity. Okay? Again, ignore the fact that it's going down. I'm going from left to right. So I'm going from negative infinity to positive infinity. Okay? You know what? I should put some x values on this graph. Alright, I'll do it later. So, everything that I've colored here in green, these are increasing intervals. Alright? That's increasing, and that's increasing. So, intervals of increase. Now, remember, I'm only doing the x values. So, the intervals of increase. Okay, this first interval starts from negative infinity, alright, comes in from the left forever, so it starts off at negative infinity. See the arrow. So I start off with negative infinity, and then it ends right here at negative 6. So negative infinity to negative 6. Now, right at negative 6, it's neither increasing nor decreasing. It's increasing up to negative 6, it's decreasing after negative 6, but right at negative 6 is flat. So we leave this round to show that the negative 6 is not included in the increasing zone. So that's my first increasing. Notice negative 6 is an x value. We're doing x values. Now, the other increasing interval starts right here, and it ends right here, okay? X value, please don't say negative 6 because you see it's so close to this negative 6. That's a y value. I'm not going to say anything about negative 6. The x value of this is like here, okay, looking directly up. So it's really going from here. And again, looking at the x value, okay, this green interval goes from here to here. Okay, it helps if you sort of look at it through the eyes of a vertical line. Okay, using a vertical line as a guide. Okay, this interval goes from here, alright, all the way over. That moves pretty slow, doesn't it? It moves from there to there. Okay, so that's why this interval is going to be from, let's call it negative, I'm going to say negative 1.4. And then it ends at, I'll say, let's call it 4.5. Okay, those are my two increasing intervals. The main thing is to make sure you're only using x values when you do this. Alright, not y values. Alright, now the intervals of decrease, same type of thing. Alright, the red zones are the intervals of decrease. And so we have one that goes from here to here. Sorry. It's like 4:30 in the morning. So sorry if my voice sounds a little tired, but I got up early for this. So it starts off here, and again I'm going to use these vertical lines to remind you that we're doing x values. So this red decreasing part starts here and it ends here. Okay, it goes from here to here. So concentrate on the x values. So that's negative 6 to negative 1.4. Okay, so it goes from negative 6 to negative 1.4. Alright, round parentheses as I explained. Right at negative 6, it's neither increasing nor decreasing. and right at negative 1.4, it's neither increasing nor decreasing. Okay? And then the other decreasing interval is this one. And I guess I'll borrow these one more time. Alright, because it goes from here. And then, you know, you're tempted to say to here, but then you remember that it really keeps going forever. So then we'll just say positive infinity. I'll just put it over here. Okay, so it starts here at 4.5, and then it really goes forever. So 4.5 to infinity, positive infinity. Okay, not negative infinity. Alright, don't look at the fact that it goes down. We're doing left to right, and on the right side here it's positive infinity. So it's 4.5 to positive infinity. Going to the right is positive infinity. Alright, now I know I went through that very slow because that's one of the things that a lot of kids have trouble with. Alright, so hopefully you understood what I was talking about. Alright, now x-intercepts. Obviously x-intercepts are x values. So I have an x-intercept here, and here, and here. There are 3 x-intercepts. X-intercepts are ordered pairs, so we will say -6, 0, and 2, 0, and 6, 0. Alright, those are my 3 x-intercepts. I also have a y-intercept, which is right here. And that is 0, -5. Excuse me. 0, -5 is my y-intercept right there. Okay, now end behavior. Well, on the left it falls, and on the right it falls. So this part of end behavior never changes. Okay, we'll say as x approaches negative infinity. Alright, that refers to the left side. F of x approaches. Okay, and that never changes. And then we'll say as x approaches positive infinity. Okay, because now we're talking about the right hand side, so we say positive infinity. F of x approaches. Everything I just put in red never changes. All of that is the same for every end behavior problem. Okay, because it just means on the left side the function does something, and on the right side the function does something. Alright, negative infinity is left, positive infinity is right. But then on the very end, we're going to say what happens on the end. So on the left side, the function falls forever. So we will say approaches negative infinity. Alright, that's the only part that changes. And on the right side, again, it falls forever. So we will again say negative infinity. So just these two, the blue part is the only part that changes. So if it's going up, on the left, we'll do a positive infinity here. If it's going down, we put negative infinity. So this is down, down, so negative infinity, negative infinity. You could really just memorize the red part because it won't change. Alright. Is there an absolute maximum? Is there a point that's the absolute highest point on the graph? Yes. Alright, the absolute maximum, hold on, I lost my arrows. Okay, the absolute maximum is right here. Alright, this is the highest point on the graph. Okay, so there is an absolute maximum at 4.5 comma 4.7 or something like that. All right, 4.5 comma 4.7. Now, if you said 4.5 comma 4.5, I would give you that. All right, but just give me some decimal to show that you see that it's in between the lines. Is there an absolute minimum? No, there's no absolute minimum. I'm going to write none. This graph goes down, down, down forever, so there's no minimum. Don't put negative infinity, all right, because that isn't a minimum. So, no absolute minimum. Now, is there a relative maximum? Meaning, is there a point that's at the top of a hill, even though it's not the highest point on the graph? Yes. Maybe I should go ahead and label these. This right here was the absolute maximum. Okay. There was no absolute minimum. Now, this point right here is the relative maximum. All right, it's the highest point on this hill, even though it's not the highest point on the whole graph, because that would be absolute. So yes, there is a relative maximum at -6, 0. Is there a relative minimum? Yes. All right, there's a relative minimum right here. And that's going to be, let's say, what was I calling it before? -1.4. Okay, -1.4 comma -6. All right, it's relative minimum. It's at the bottom of this valley, even though it is not the lowest point on the graph. So that makes it a relative minimum. Okay, and what is the value of f of 5? So you should be asking yourself, wait a minute, is this 5 an x value or a y value? Now I tried to teach you that function notation works always like this. F of x equals y. This is the format. So anything that's inside of here, this is an x value. And whatever's out here is going to be a y value. So that means this 5 is an x value, and what I'm asking you for here is I'm asking you for the y value that goes with it. So go to an x value of 5 and then look around and see where the y value is. Let's see. I'll go ahead and use the green for this. So here I am at an x value of 5. Okay? And I look up and I see that the y value is here. Okay, so this is so at an x value of 5, we see that the y value that goes with that is 4. So f of 5 equals 4. All right. Alrighty then. Microphone stopped working for a minute. Let's see. So we're supposed to solve each of the following inequalities algebraically, showing all steps, and we'll graph the solutions on the number line here. To do this, we need this to be in standard form. We're going to factor. So basically we're moving the 7x over that direction. I'm going to zoom in. So let's see, I can write a little finer. So let's subtract 7x from both sides. Okay, so I'm moving that over. So subtracting 7x from both sides, what we have is x squared minus 7x plus 6 is greater than 0. So we can easily factor this, which is key. And because x squared can only be x times x, and 6 is either going to be 2 times 3 or 6 times 1. Now, with an eye on the 7, we're really looking at the 1 times 6 option. Okay, because I'm seeing the 7. So, you know, inner we have 1x, outer we have 6x. If we're trying to get a negative 7 out of this, that can happen if both of these are negative. So we're talking about negative 1 and negative 6. Okay? So, and a negative times negative is a positive, so this is looking good. We will get the x-intercepts because the idea is this is a parabola. Okay? So there's a parabola happening here, and we're looking for the x-intercepts right now. The x-intercepts will always be at 0, where x equals 0. So I can find the x-intercepts if I set these little guys equal to 0 like this. Alright, setting these factors equal to 0 will always give me the x-intercepts. So adding 1 to both sides, that's going to give me x equals 1. And adding 6 to both sides will give me x equals 6. Alright, we're not really going to draw the parabola. But, so, we know that we have x-intercepts at 1 and 6. So, we will put those two marks on the graph here. So, let's say that 1 is right here, and let's say that 6 is right here. Alright, those are really the only two numbers I need to see on the number line. Okay? Now, this divides the number line into 3 zones. We have the zone on the left, the zone in the middle, and the zone on the right. What we discussed previously is we need 3 test values to see what's going on here. So, let's see. To the left of 1 is 0, so I shall definitely use 0. In fact, let me just keep myself organized here. Okay, alright, I'm going to make a little chart to keep my work straight. Okay, so in this zone here, a good value to use would be 0. Alright, using 0 makes the calculation simpler, so I recommend it. Now here between 1 and 6, I can use any value I want. I'm just going to use 2. Alright, I'll just use 2, because why not? And I need a value that's to the right of 6, and I'll just use 7. Alright, so these are the 3 test values I'm gonna check out. So let's see. I'm going to use the factored form to test these values. So if I plug in 0 for these x's, then this is going to become 0 minus 1 times 0 minus 6. Okay, but 0 minus 1, so that's just negative 1 times negative 6. Well, that makes positive 6. Okay, and the question is this greater than 0? Well, yeah, 6 is greater than 0, so that's a yes. Alright, file that away. That tells me that 0 is a solution. That means everything in this zone is a solution. Before I go any further, I should look at 1 and 6 itself. Now, so at 1 and 6, it's either going to be open circles or closed circles. All right, either these are solutions or they're not. Well, 1 and 6 are where the graph equals 0. But we want we just want the values that will give us values greater than 0, not equal to 0. So because it's greater than and not equal to, there's no or equal to happening here, then these will definitely be open circles. So we'll have an open circle at 1 and 6 to show that they are not included in the solutions. Now back to the test values. Looking at 2, if I put in 2 instead of 0, then this becomes 2 minus 1 times 2 minus 6. 2 minus 1, so that's going to be 1 times negative 4, which is negative 4. So the question is that greater than 0? Well, no. All negative numbers are less than 0, so that's a no. That means there will be no solutions in this area. 2 is not a solution. None of these values will be solutions. And then finally we'll test the third zone. So if I do 7 instead, so this will become 7 minus 1 and 7 minus 6. Alright, 7 minus 1 is 6, and 7 minus 6 is 1. 6 times 1 is 6. So the question is that greater than, I forgot my question mark, is this greater than 0? Of course, 6 is greater than 0, so that is a solution, yes. So 0 was a solution, which means that everything in this zone will be a solution. So I'll show that with an arrow. 7 was a solution, so that means everything in this zone is going to be a solution. So there we've graphed the solutions with these blue arrows and open circles. But we also have to write the solutions up here like an interval notation. So this piece on the left, this is negative infinity to 1. So I will write negative infinity to 1. And the 1 will get a round parentheses. This is an open circle. 1 itself is not included because it's greater than, not equal to 1. I'm sorry, not equal to 0. And then we'll put a union symbol because we have two pieces that we're trying to include both of them, so you need that union. And this part goes from 6 to infinity. Alright, so I will say 6 to infinity. Alright, again, round parentheses on the 6 because it's an open circle. It's not included. Okay, so that is how you do that. Number 3 is really the same thing, just it's a little bit just slightly trickier with the factoring and all. So again, we need to move that 6 over. So, you know, let's subtract that 6 from both sides. So that's going to give us 3x squared plus 7x minus 6 is less than or equal to 0. If I factor this, three x squared can only be 3x and x. Okay? Now, this 6 could either be 2 times 3, or it could be 1 times 6. Alright, those are the two possibilities. Now, I cannot immediately start looking for the 7 this time. Like last time, I saw the 7 and I went, oh, 1 and 6. 2 and 3 don't make 7, so I just went with the 1 and 6. But I can only do that when when the leading coefficient is 1, like this. Alright, when there's no number in front. This time, the leading coefficient is 3. So I have to look at my inner, outer equals middle. So I'm just going to start with the 2 times 3 instead. Okay, so, and if it doesn't work out, I'll erase it. So you should be doing this in pencil. So this is going to be, I'll try 2 and 3. By the way, you should not be watching this video with a pencil in your hand. If you have a pencil in your hand, you are not following my instructions. Watch the video, learn how to do it, and then go back and do it yourself to make sure that you can do it yourself. You won't have a video to watch during the test. Okay, so I'm trying this. Inner, I have 2x. Outer, I have 9. I'm trying to get a positive 7. I can get a positive 7, middle, if I have a negative 2 and a positive 9. That will make positive 7. So here's my negative 2, and this would make my positive 9. And a negative times a positive is a negative, so that works as well. Alright, so that means we factored it correctly. Okay, so now I need to set these equal to 0. Okay, let me just wall that off. So I need to do 3x minus 2 equals 0, and I need to do x plus 3 equals 0. Okay, so that's going to give me, because I will add 2 to both sides, so that gives me 3x equals 2. And then I will divide by 3, so I get x equals 2/3. Alright, so this is one of my solutions. Whoa. Alright, I really wanted to do that division in a different color is all. I think I'll just use gray. Okay, so I have x equals 2/3. The other one is a little simpler. I'll just do minus 3 on both sides, so I get x equals negative 3. Okay, so these are my two x-intercepts of this parabola. Okay, are going to have x-intercepts at negative 3 and 2/3. So those are the two values that I must include on my number line. Okay, so I'll put my negative 3 right here. And let's see, how much space do I have over here? Lots. So I'll put my 2/3 over here. Okay, I think I might need a little more space than this. Let's see, so I'll put my negative 3 here. Alright, so I've got negative 3 and 2/3. Obviously 2/3 is less than 1. Alright, 2/3 as a decimal, you know, is like 0.6 repeating. Okay, that's 2/3. It's less than 1. Keep that in mind. Okay, so this is the point at which we need to make our test values. So I have these 3 zones. Okay, so in this first zone right here, I have negative 3. So I will go ahead and use a test value of negative 4. I just needed something to the left of negative 3. In this middle zone, I will use 0, because 0 is between negative 3 and 2/3. And in this zone, I will just use 1. Alright, because 1 is bigger than 2/3. Alright, which is like 0.6. Alright, but I could have used 2 or 3 or 4 or 5. You could use anything you want as long as you have one value in each of these zones. So as I substitute these in one at a time to see what I get. Okay, so I have 3x minus 2. Alright, I think I'm going to need a sharper pencil. Okay, so this is going to become, this is going to be 3 times -4 minus 2. Okay, and then -4 plus 3. All right. So, 3 times -4 is -12. So I've got -12 minus 2 and -4 plus 3. All right, -12 minus 2 is -14. So I've got -14 and -1. All right, -14 times -1 is +14. So the question is +14 less than or equal to 0? All right, and of course that answer is no. No, it is not. Okay, so that's -4 is not a solution, so nothing in here is going to be a solution. Now what about 0? If I do 0, then that means I'm going to have 3 times 0 minus 2, and then 0 plus 3. Alright, 3 times 0, so that's just 0 minus 2 times 0 plus 3. So that's just -2 times 3, which is -6. So the question is that less than or equal to 0? And yes, any negative number is less than 0. So yes. That means 0 is a solution, so everything in this area is going to be a solution. And finally, I will try a value of 1. So this would become 3 times 1 minus 2. Okay, I'm just plugging it into that. And 1 plus 3. Okay, so 3 times 1 is 3, so that'll be 3 minus 2 times 1 plus 3. 3 minus 2 is 1, so that'll just be 1 times 4. Alright, 1 times 4 is 4. So the question is that less than or equal to 0? Alright, no. 4 is greater than 0, not less. So we have a no, a yes, and a no. So no solutions here. We have solutions here. We don't have any solutions here. Let's talk about the X-intercepts themselves. The X-intercepts give you equal to 0 if you plug them in. All right, that's where they came from, equal to 0. And we want the values that will give us less than or equal to 0. So equal to 0 is okay. So we will use closed-in circles to show that these X-intercepts are included in the solution set. All right, so we're including the endpoints, and then the solutions are here in the middle. So we will just draw a segment between to show that everything in here is included. All right, so there we've graphed it. Now the way we would write this in interval notation would be like this. We're going from -3 to 2/3. So we'll put -3 to 2/3. And this time we're using square brackets. All right, for the same reason we put closed circles. It's or equal to 0. So we will include these endpoints. All right, that took a while, but we did it. Okay. All right, rewrite the following quadratic equation in vertex form. All right, vertex form is like this. It's y equals a times x minus h squared plus k. I mean, this is not something you have to memorize per se, but I just want you to have in the back of your mind, when I say vertex form, I'm talking about a form that has parentheses, squared. You know, I just want you to know what our goal is. It looks something like this. Okay, so we have to change this into vertex form. Now, what you have to remember is we convert this to vertex form by completing the square. Now, this is the tougher kind of completing the square because it's got this leading coefficient. So be careful. Most of you guys, to be honest, you usually get this wrong. But hey, better late than never. Maybe now is the time you're about to learn. So completing the square. So the first thing we need to do is move this 187 away. So we can accomplish that by subtracting 187 from both sides. Alright, minus minus. So that's going to give us y minus 187 equals 5x squared minus 60x. Now, so what we're doing is completing the square. Maybe I should make a note to ourselves that we are completing the square. Complete the square. Alright? Now, nobody's going to tell you to complete the square. You have to know that that's how you make vertex form, is by completing the square. Okay? So do not make the mistake of doing half the middle squared right now. That's a common mistake. You can't do that while there's still a leading coefficient sitting here. So the way we deal with that is we factor out the leading coefficient. So I'm going to keep this y minus 187, okay? But I'm going to factor out this 5. So that will leave behind x squared. Now, to understand what I'm putting here, if I factor out a 5, that means I'm going to divide by 5. That tells me what goes in here. So these 5's canceled out. That's why I just have x squared in there. But then 60 divided by 5 is 12. Okay, so I'm going to have minus 12x in there, and leave a space to complete the square. Okay, don't believe me on the multiplication fact, right? 60 divided by 5 is 12. Okay. Now we complete the square. Now we do half of the middle squared, and we put it here. So half of the middle, so half of 12 is 6, and then 6 squared is 36. So this is always positive, so this will be 36. So if you made it this far, you avoided the one big mistake of doing 30 and squaring that and getting 900. Alright, putting 900 here would be totally wrong. But now you have to avoid the other mistake that kids make when there's a number here. Some kids will think I'm going to put my plus 36 over here, as we often do. But no, this looks like a 36. It's not a 36. Why? Because of the 5. Alright, this is in parentheses. This could easily be distributed. So in your mind, you have to imagine doing the distributive property with the 5 to turn it back into the previous form. And if you did, you'd have 5 times 36. So this looks like a 36, but it's really, maybe I'll just put a note in green, gray. Okay, this looks like a 36, but it's really 5 times 36, which is 180. So it looks like a 36, but it's really 180. So instead of adding 36 to the other side, I'm going to add 180 for this reason. Okay, you have to multiply by this, and that's what you put over here. Okay, then I can finish the problem. So far then I've got y minus 7. Alright, negative 187, positive 180, that's negative 7. Equals 5. Now, this should now factor as the same thing twice. Alright, I've had people get to this point and go, oh, it's unfactorable. Well, guess what? If it's unfactorable, you messed up. Okay? The whole point of doing this is to make it factor, and specifically it should factor as the same thing twice. X minus 6, x minus 6. Usually it's because kids are not forgetting to factor out the 5 first. And they're just sitting there with 5x squared and they're trying to factor with that. Pull the 5 out, and then we're just factoring this trinomial without the 5. So x minus 6 times x minus 6. So that means I have y minus 7 equals 5 times x minus 6 squared. Alright, because that's the same thing twice. See how we're getting closer and closer to this form? Alright, I've got my parentheses squared. I've got my a value. Is there 5? But where's my k? Well, my k is over here by accident. Okay? So I say we add 7 to both sides. So plus 7 plus 7. So that's going to give me y equals 5 times x minus 6 squared plus 7. Okay, let me put it out here in a more visible place. Y equals 5 times x minus 6 squared plus 7. This is vertex form. Alright, I also could have asked you for the vertex or the axis of symmetry. Okay, so you should be prepared for that. In fact, maybe I'll add that to the question. Alright, probably by the time you get this paper, it'll be printed on there. So, oh, look at that. We're supposed to find the vertex and the axis of symmetry. So, looking at this, what's the vertex? Well, the vertex is going to be the opposite of this one, comma, that one. So the vertex should be, whoa, why so heavy? It's not cool. Alright. The vertex is going to be 6, comma, 7. Alright, the opposite of this one, comma, that one. And then the axis of symmetry is always going to match the x value here. So x equals 6. Alright? So that means there would be a vertical line down the middle of the parabola at 6. Alright, so that's it. That's how you rewrite an equation in vertex form. I've got to remember to add this to your paper. Alright, moving on. Find the determinant. Do not forget about this. There will be review stuff from matrices on the test. Okay, so remember that to do the determinant, you just do the down diagonal minus the up diagonal. So the determinant, let's call this matrix A. So the determinant of matrix A is just going to be the down diagonal minus the up diagonal. Okay, so that's going to be negative 10 minus negative 12. Okay, and please be careful. Don't just say negative 10 minus 12. It's negative 10 minus negative 12. It's minus a negative. Okay? And if you're doing this by hand, then you have to understand that minus and negative is addition. So this is going to be 2. Alright, so the determinant is 2. Now, number 6, we're supposed to graph this. And I gave you like a table to record your stuff. You should know that the vertex is, let me just jot this down. The vertex is going to be -2, -4. Okay, it's the opposite of this, comma that. So -2, -4. And you should put that in the middle of your table, -2, -4. Okay. Then I would use the calculator. Let's go to table and type this in. So we have x plus 2. Whoops. I am messing up. Better start over. X plus 2 squared minus 4. Alright, there we go. Let's take a look. Now, we want, looking at the table, if this is -2, then, you know, as we go, less than that would be -3 and -4. And greater than that would be -1 and 0. Okay, but this is the vertex. Always put your vertex in the middle. So I just did that real quick so I could remind me I need to start at -4. So I'm going to tell it to start at -4. Okay, so I see we have -4, 0, and then so I've got 0 and -3, and then -4. So 0 and -3 and -4. Now if we did this right, then this should be -3 and 0 again. And sure enough, -3 and 0 again. So we have our table of values that we can use. So our vertex was -2, -4. So that should be our vertex right there. And then -3, -3. Okay, and -4, 0. Okay, and then -1, -3, and 0, 0. That's all that fits on the table. But if there are more values you can get off of your calculator, I want you to graph all of them that will fit. So keep going. Don't just graph these 5 values just because that's all the space you had on your table. Your calculator has more. So I see I have 1, 5. So that would be right here. Alright, and there should be a mirror image right here, correct? Are there any more values from your calculator? Let's see. And then 2, 12 doesn't fit anymore. Okay, so we just got 1 extra pair of values. And then you should go ahead and sketch the graph as best you can. Okay. Alright, that's looking pretty good. Alright, let's move on. What else we got? So we graphed that. Alright, now we're supposed to write a quadratic equation that has a maximum. It has a maximum, and then it has these zeros. Okay? Okay. If it has a maximum, then that means that it must be upside down. Okay, so parabolas either go like this or they go like this. Okay, if it has a maximum, then it must be an upside down function. Alright, if it's an upside down function, then that means it's there must be a negative in the front. Alright, that's how we know it faces upside down. Now the zeros, which are the numbers that occur at the x-intercepts, the zeros come from, we could do this in factored form. So, like, remember when we did, when we did these problems, these would be the zeros, like 1 and 6, they were these x-intercepts, right? 1 and 6 were the zeros. Well, 1 came from x minus 1, and 6 came from x minus 6. So, see how it's kind of the opposite when you write it in factored form? So if you look at that, alright, -2, what factor would give me a 0 of -2? Alright, well, if this were x plus 2, that would give me -2, because then I would go, oh, x plus 2 equals 0, minus 2, and then I'd have x equals -2. Alright, so a 0 of -2 comes from a factor of x plus 2. Whoa, why are you messing with me, man? Okay, and of course a 0 of 7 is going to come from a factor of x minus 7. Now, I didn't say that you had to put it in standard form. So if I don't specifically say that you had to put it in standard form, then you could just leave it like this. This would be an equation that is a quadratic function, and it has a maximum because it's upside down because of the negative, and it has zeros at -2 because of this, and positive 7 because if I set this equal to 0, x minus 7 equals 0, and then that would be plus 7 plus 7. That would give me the 7. Is it going to jump again if I do this? Okay, so you could just leave your answer like this. I would accept this for an answer. Now, if I said to put it in standard form, you'd have to multiply this out. So this would be like negative, x times x is x squared. Inner, we've got 2x. Outer, we have -7. Together, that would make -5x. And then 2 times -7 is -14. So we have this, and then that would give us, I'm just distributing the minus sign like a -1. So that would give me -x squared plus 5x plus 14. This would be same answer in standard form. So if I ask you for standard form, you got to give me this. Alright. Now, so that was everything on this front page. That was like the new stuff. That's the stuff we've learned since the quiz. Now, the stuff on the back page, this is what we actually reviewed yesterday. Factoring and solving. So we'll just we'll review it again. Now, the first step of factoring is looking for the GCF. So both of these are divisible by 2. So I would pull out a common factor of 2 if I were you. And so that's going to leave 4x squared minus 49. And hopefully you realize that this is the difference of two squares. So you keep going and you say 2x plus 7, 2x minus 7. Okay, so that would be how you do number 8. Number 9, look for the GCF. There's no common factor, so we'll go ahead and go straight to binomial times binomial. Oh, by the way, notice we stop. It's not an equation. Do not set these equal to 0. Do not try to keep going. 2x squared can only be 2x times x. 25, I'm betting on 5 times 5. Inner, we have 5x. Outer, we have 10x. We're trying to get negative 5x. We can get negative 5x if this is a negative 10 and a positive 5. Well, this is the positive 5, inner, and this will give me the negative 10, outer. Also, a positive times a negative is a negative, so that tells me that this is factored correctly. Okay, looking at number 10. Look for the GCF. There is one. They're all divisible by 2, so you must bring that out. Alright, so many kids don't do that no matter how many times I say it. Always, always, always look for a common factor. So that's going to leave in here 3x squared minus x minus 2. Then you can go ahead and factor it from there. 3x squared can only be 3x and x. 2 can only be 1 times 2. But it might be 2 here and 1 here. Inner, we have 1x. Outer, we have 6x. Okay, look, I'm trying to get a negative 1, so this is not working right now. So let's switch it up and try putting the 2 here and the 1 here. Now inner, I have 2x. Outer, I have 3x. I can get a negative 1 if I have a negative 3 and a positive 2. So there's my positive 2, and this will give me negative 3. Also, a positive times a negative is a negative. So this is the answer. And stop. Do not set these equal to 0. This is not an equation. Don't put an equal 0 on here that's not there. Okay, number 11. Look for common factor. The common factor, well, they're all divisible by 2. So I would bring out the 2. Okay, I'd bring out the 2. So, oh, and they all have an x. So we should bring that out as well. So we'll bring out 2x. So remember, when you pull out a GCF, you're dividing. Okay, you're dividing and then you're putting it out front. So this is going to leave behind 6x squared plus 11x minus 10. Okay, and then we will factor the trinomial. So I will have 2x, and then, now this 6 can either be 2 times 3 or 6 times 1. I'm going to try 2 and 3 first. If this doesn't work, I will go back and do 1 times 6. Alright, now 10. 10 can either be 2 times 5. Alright, this is either going to be 2 times 5 or 1 times 10. Alright, and just like this could either be 2 times 3 or 1 times 6. So I'm trying 2 times 3, now I'm going to try 2 times 5. Now I'm not going to waste my time putting the 2 here and the 5 here. Putting a 2 here would cause a common factor. That's a waste of time. That will not be the answer. So I will try 5 here and 2 here from this. Inner, that would give me 15x. Outer, that would give me 4x. Alright, I'm trying to get positive 11. And I can get positive 11 if this is positive and that's negative. So positive 15 inner comes from this. Negative 4 outer comes from this. Also, a positive times a negative is a negative. So guess what? We have factored it correctly. Okay. Number 13. GCF. Always look for the common factor first. These are both even, so I know at the very least they're both divisible by 2. So I'm going to pull out a 2. Alright, that's going to leave 8 x to the third power minus 125 y to the third power. Now, hopefully you recognize this as the difference of two perfect cubes. Alright, 2 to the third power is 8. And 5 to the third power is 125. I recommend making a whole list of these on the side of your test paper as soon as you get it, just using your calculator, so you can recognize these special numbers like 8 and 125 when you see them. Then you have to just remember the pattern. If you have the sum or difference of two perfect cubes, and both of these variables have to be cubed if they're there, it's always going to factor as a binomial times a trinomial. Okay, a 2-piece and a 3-piece. The binomial just comes, it's going to be the cube root of these. 8 comes from 2, so I'll have a 2. 2x. Alright, the sign is the same. 125 comes from 5. And then y to the third power comes from y. Okay, let me tighten this up a bit. So there's my binomial. Now my trinomial. Okay, I like to do my beginning and end right now. The first term just comes from squaring the first term. If I take this and I square it, I'm going to get 4x squared. You just square this. If I take this and I square it, that will give me the ending number. This is going to be positive 25. Now do not ignore the y. Some kids leave this out. This is going to be 25y squared. You have to square the y too. We're squaring all of this. So positive 25y squared. Please make sure you have y squared. And then the middle. The middle comes from multiplying these two together and doing the opposite sign. So the middle is going to come from doing 2x times negative 5y. This would make negative 10xy. So we put positive 10xy. You just multiply these together and do the opposite sign. So that is how you factor this. Okay, do not leave out the 2. Don't just divide and get rid of it. That 2 is still there. Okay, looking at number 14. Once again, first step of factoring. Look for the GCF. Both of these are divisible by 7, and they both have at least one x. So 7x is the common factor. Alright, so to figure out what goes inside, I will divide by this GCF. Alright, make my parentheses. So 14 divided by 7 is 2. X to the third power divided by x is x squared. Plus, those 7's cancel, those x's cancel, and then I have y to the third power. Alright, this is a binomial. It's not the difference of two squares, which is one way that we can factor a binomial, and it's not the sum of two cubes. This is not a cube, 2 is not a cube. So this cannot be factored any further. A lot of kids will try to factor this more, but you can't. That's the answer. Okay, I am not going to finish this. Let's see. This is probably going to be a good place for me to end this video. I'll make a separate video for the rest of this. Yeah, and you can consider that like the rest of this is like your homework or whatever. I wanted to make the first part something that you could watch in class for classwork. But the rest of this video will be posted this afternoon or this evening, so you can use it to finish tonight for homework. But it's time for me to go to school, so I have to stop.